Hi, you're listening to Pop Goes the Stack, the podcast that treats emerging tech like an incident report, root cause to be determined. Impact probably your weekend. Usually is, especially on a Friday. I'm Lori McVitie, and my co-host Joe Moses is back from his fine-tuning exercise.
Thanks, Lori.
I can't wait to hear what you've learned while you've been kind of on a break, because today we're going to talk about the newest bright idea in AI. So don't pay humans to evaluate model outputs, right? If we're looking for hallucinations or, is it kind of gone wonky? And don't let humans tell you that. Let another model do it. And it's called LLM-as-a-Judge. And there was a great paper on it and that was written about it. And where it talks about this thing called preference leakage. And apparently when models in the same family look at their baby, they all say, yes, it's beautiful. Essentially, this is a problem. So to talk about it, we brought distinguished engineer Ken Aurora back to talk about this. So yeah, let's jump in. Let's talk about preference leakage and judges and models and should I be scared?
Well, let's first start by talking about why judgment systems are necessary. Ken, why don't you explain to us what first of all what LLM judging means? Why is it necessary? What does it do?
Well, any system, any machine learning system, fundamentally needs some sort of feedback, some sort of way of saying, "Am I doing the right thing? Am I not doing the right thing?" And that feedback can come in many forms. As Lori said, sometimes that's humans saying right answer, wrong answer. But humans are expensive and take a lot of time and slow and all the problems that organic life forms have. So one of the ways to deal with that is to say, well, why don't I just have the model? I'll do something else. And there are a lot of approaches that have been used, and I could talk for a while. This is our podcast about different ways of doing this, but one of the techniques that people have tried using and are using is, let me use another model, right? It's sort of like phone a friend. It's like, okay, I think that's the answer. Let me phone a friend. And therein lies the rub. I'm going to toss this back to Joel because Joel actually played with this. But the idea they found is, if you phone a friend and that friend is somebody who is very much like you, like a twin brother, maybe you shouldn't be surprised if that answer has a bit more bias to it than if you phone somebody random.
Yeah. I'm going to try to stay a little bit above the philosophical aspects of keeping everything inside the family and creating structures that are essentially in the same family. But it is true. So whenever you're creating a judgment, whenever you're trying to determine the quality of the output or the quality of the content going in, setting an LLM that judges the output of something that's being prompted is a way to very quickly figure out whether the content is accurate, whether it's complete, that the whole nine yards. However, this research paper, and we're going to link it below, says that if you use the same basic model or model family, now I think that's also interesting to note. So when I say model family, like there are different families, like the ones from OpenAI, the GPT-4o line, and continuing, and then there's Gemini and there's Llama. But when you point the model at its counterpart, meaning if I use an OpenAI generated model and I test it or I judge it using an OpenAI generated model, that there is some inherent bias that the output is better than it is, and the paper goes into some detail about how that might be the case. It makes a lot of assertions, but it statistically indicates through a variety of battery tests using some very popular LLM tests that this could possibly be the case. And it seems to be isolated to models within the same family. So that's an interesting outcome. Now, how severe is that problem? The paper classifies it as a vulnerability of judgment systems. It also goes on to talk about how this particular vulnerability might be used to determine what system is judging the output of an LLM, and has some interesting things to say about that. But in the end analysis, it still indicates that even when judgment systems are used, they tend to still improve the output. Right. So I'm not sure you can classify this as a vulnerability. It's more of an odd characteristic of judgment systems. Do you agree?
Yeah, I think that's true. It's a little bit of I am sorry, I'll go back to being a little more philosophical, and just the analogy here is maybe this isn't as I mean, maybe this is a symptom. The fact that you have this bias, I like that word better. It's, this preference leakage sounds like a medical condition. Um, uh,
I
um,
there is a chemical solution for that, I'm pretty sure.
okay. But yeah, this systematic bias that, and yeah, and this isn't just one, right? There, this idea of, panel of experts, mixture of experts has been around a long time
Mhm.
in AI. Um, I step back and I go, I wonder how much this is also really, in fact, reflective of these things in a family are often trained in a similar way, and their training sets have similar goodness metrics that they're going after. So what you're really seeing is a reflection. It's a symptom of the fact that these models, again, to make them anthropomorphize them, grew up in the same family, in the same culture. So
Hmm.
of course they're going to have the same biases. If I grew up in a small town in Texas with a small family, it's going to be very different than if I grew up in, middle of Delhi with, a extended family and 10 million of my best friends living in that same city. And it's going to just be reflected in my worldview. And
Right.
you could say, oh, well, yeah, there's bias there. It's like it's reflective of the backstory.
And that's it. I'm not sure it's a problem or that there actually is an answer. And some of this seems to be like we're searching for an answer to an unsolvable problem, because it's, if I asked Joel, uh, you know, is this correct? And then I ask someone else, is it correct? I can get two different answers. And when it's not, to use the word, right, deterministic. I mean, it's there. 2 + 2
Right.
is 4. Everybody should give me that answer. Um, but if I ask, how, is 70 degrees a good temperature? I, well, you're going to get different answers, right? So
Yeah.
how do you decide if that's correct? Correct for who and correct
Mhm.
for what?
Yeah.
Yeah.
And so that transfers over into even things like, business, where I'm writing an email. Is that correct? Well, who are you talking to? Who is it coming from? What's the topic? What's the context? And there's 100 different variables that impact, is this a good, as you pointed out, email? And that's what we're asking it to judge. Is this, right, completely, you know, randomly
Yeah.
generated bunch of words that describe something?
Yeah. Now, I want to be very clear about what this preference leakage concept is, and separate it from the concept of data leakage, which is a
Yeah.
related
Mhm.
but different thing.
Okay.
So a data leakage is where you have a training corpus. You've got a bunch of stored data, and you use that to train a model, and then you run an evaluation test set against it, and there's a bunch of different evaluation test sets against it, and then you evaluate the output of this trained model and discover where it is leaking certain information through directly from the training corpus. Okay, so that's one element of leakage. Now, in order to guard against that, sometimes what you can do is you can generate synthetic data alongside other data and feed that into the training set, which tends to improve its ability to be resistant to data leakage. But what this paper is saying is that if you use the same model to generate synthetic data to train the model itself, and then you judge it using a system that uses the same model, that there's an inherent relatedness bias,
Mhm.
and that it will tend to score higher because the model that generated the synthetic data that it was trained on, and the system that is judging the veracity of the output, they have some sort of connectedness,
Mhm.
and because of that, the scores look skewed.
Mhm.
And that relatedness can sometimes put at risk your ability to defend against things like data leakage, or to detect and stop things like hallucinations using a judgment-based system.
Mhm.
So it's kind of a backside evaluation problem. And that's an interesting concept. Like if you're generating data from a particular model and you're evaluating it using the same model or model family, that the relatedness of what generated the data and the relatedness of what is evaluating the data, there's a connection between the two, even though they are not physically connected in any way. And that is a fascinating outcome. Although I think it's kind of something that you should expect. The main corpus that you're creating the synthetic data from is the same, and what it was trained on is the same. So there will be some sort of correlation there.
Yeah. I think you use the word right, even though they're not connected. I nuance that as they're not directly connected. But they are indirectly connected because they have that same training set. It's the synthetic data you generate can only be emitted from the universe of that space that model is aware of. If I go back to that again, human analogy, if I grab somebody from the tropics and I ask them questions, odds are that I'm not going to have a lot of synthetic data that's generated is going to talk about the nature of the 17 types of snow that the Eskimo knows about. And so of course there's going to be a blind spot there, and they're going to answer things. They're going to say, oh, do I need to worry about, I don't know how I build a roof? And it's like, oh no, roofs are fine. You put a flat roof, it's fine because rain will fall right off. Because they're never thinking about snow loads and things like that to kind of push this analogy a bit further than probably I should have. But yeah, it's their universe.
Right. That's the way that the model, I hate to say, we keep saying model was trained, but it builds weights and relationships in the training data. And those same weights and relationships exist in other models that were trained with that data. So it makes sense that if you ask the question, get an answer, and then you feed it and say, hey, is that good? Well, it's got the same values and weights inside of it. It's going to be like, well, yeah, it's good. Yeah. I'd say the same thing.
Yeah. So what do we do about this? I mean, that's the obvious question. So, it's a common practice inside of engineering or working with these models to kind of judge their outputs using evaluation tools, things like Llama Factory, Alpaca Eval, Arena Hard. There's a whole bunch of test kits out there. It's becoming a much more common practice in the AI space to look at your models with a critical eye for security purposes. So red teaming of models is increasingly something that security practitioners are used to. So I think what this paper is kind of pointing out is a condition where you need to look at the evaluation of the AI model kind of like a security person would look at defense in depth strategies. Meaning you don't necessarily protect using one technology, you protect using a variety of technologies in the same way, so that if it passes muster with one, it may not pass muster with another. A diversity, so to speak, of security protections. And so I think that this is pointing out the need to, when you're doing red teaming, to have diversity in the evaluation set.
Yeah, it makes sense. If I write something, right, you see it, you become so familiar with it that you often miss little things like typos or little grammar, right, errors that when an editor looks at it, which is why we have them, will find them for you because it's a fresh set of eyes. It's a different perspective. They haven't looked at it 100 times. So having some external system, right, look at the outputs and judge it makes absolute sense to me, especially in something that's so varied as generative AI.
Yeah, no, totally. I absolutely. So more concretely, right? This is, I think, says and again, there's some economic considerations to this as well. But if you are developing these models, it's important to try to test them, break them, evaluate them in the context of models from different families. I think, right? That seems to be the obvious answers. Like, well, if you're going to ask about the weather, don't only ask people in Hawaii or only in San Diego or only in Minnesota.
Yeah, everything looks like snow in Minnesota, doesn't it, Lori?
I don't know. I'm not in Minnesota. I'm in Wisconsin, which is Minnesota's like neighbor. So yeah, it all looks like snow eventually, and ice, sleet.
So, I mean, the obvious question here is, what do we do in response to something like a possibility of preference leakage? There's diversity, but can you think of any other approaches, Ken, that might be useful for judgment systems, which are increasingly popular and being used for security purposes in red teaming models.
Hit me out. You hadn't asked me this out of the blue. So off the top of my head here, I'd say, another thing is this touches on another thing that I think that same research team talks about, which is hallucinations and what causes them. And there's a school of thought with some evidence that says hallucinations are caused, when you take the SAT, right? The SAT or any standardized test kind of take into account that you might randomly guess, and if there's multiple choice and you have 5 choices, you're randomly going to get 1 and 5 right if you guess. Therefore, I'm going to assume that and take that into account. A lot of the training doesn't do that for LLMs, which is maybe a little surprising. That there's a definite penalty, like it's 0 points for saying I don't know, and you get if you blindly guess and you're right 10% of the time, it means you'll hallucinate 90% of the time, but you still get 10% of the points you could have gotten. So there's incentive to guess, and that might cause hallucinations. Anyway, relating this back to preference leakage, I think that we probably need to do more to have, when you train models, even within a single family, to encourage them to say, I don't know. This is outside of my universe of knowledge. And I think that might, then when you call a friend has the freedom to say, yeah, I don't know either. Maybe you want to call a different model, because I can't evaluate whether that's a good answer or not. Because I'm definitely speculating. The areas where maybe those preference leakage will give you bad answers are cases where the confidence in the answer is pretty low.
Got it. So there are definitely implications, and this is definitely an area where we're going to need to watch the technology as it matures, and as judgment systems are used and red teaming systems become more popular, it's going to be more important to know about how those processes actually work, how evaluation processes of models actually do work. What are they comprised of? What are they built from? What models do they use, if they use models? Now, Ken, another question, and this is again, this is ad hoc, and you may have an answer to this, you may not have an answer to this, but there's also a growing popularity of systems that check output in real time. And what we're talking about today, the preference leakage, is in evaluation tools, meaning taking a model and battery testing it, not looking at prompts in real time or anything like that, but literally testing the input and the output of a model system and seeing if there's any inherent bias there. But for security solutions, for example, that are judging the output and looking for data loss within live output, it's becoming a common theme to use small language models, which are very reactive, very quick, but maybe very specialized, in order to do a quick check of an output of a user prompt. Does this research have any bearing on the use of SLMs for protecting data transactions?
I will, my off the top of my head, my thought on this is SLMs would take this, and if I believe that some significant fraction of the root cause of this is having a limited universe, and large language models have a fairly large universe, but it's just not perfect. Small language models are going to have a much more limited universe. And so I think they might be more, I would speculate, might be more biased or more susceptible to this preference leakage sort of vulnerability. The way I would tend to mitigate that is maybe having a independent model that all it does is says something, is try to evaluate how much in the domain of the small language model is it. Because when you do a small language model, you typically know the domain. So maybe you give a large language model, say, if I were to ask something trained for this purpose, would it be in the domain of expertise of it, and use that as a way of judging how much you should trust that answer.
Yeah. Well, once again, there's a ton to learn in this particular space. Any other questions, Lori?
No, I was just going to comment. I mean, we naturally go to security because I think security is top of mind right now, because this is a new system. There are so many ways to exploit them. But just the definition of, you mentioned goodness or correctness has significant implications on other areas within, the enterprise. Like, I want to choose, one of 3 models that are out there. Well, what if one is degraded? What if it's not correct anymore? Do I really want to send to it? right? So the way that we scale and distribute requests, right, app delivery, if you will, is definitely impacted by the models, right, degrading. So being able to judge correctness is actually very important to just about everything that happens in building out these systems. So this is a good place to start, and we need to be aware of it. And how can we get better at that so that we don't, right, end up with yeah, it's okay, and it turns out it's not, right? We don't want to make those kind of selections. So it's an important topic.
Yeah. Well, in a generative model, correctness is security.
I like that. See, that's a good way to sum it up.
I would say it's reliability. Should we argue about that? Is it reliability?
Sounds like another podcast to me, Lori.
Okay.
So, let's talk about some of the things we've learned today. So we've learned about something called preference leakage, and again, the paper will be linked within the body of the description. And it's an interesting paper, and it's an interesting concept to think about. I think instead of classifying this as a vulnerability, I would classify this mainly as a characteristic of models themselves. And it's something that we probably need to do a little more thinking about as we look to drive biases out of the systems that improve models and out of the systems that protect models. And so when I am looking for a takeaway from today, I'm thinking about figuring out bias in these systems. It makes me look outside now of the model itself.
Yeah. I guess if I have one takeaway, it would be sort of that, just phrased in the more philosophical human realm, which is, bias, be careful what you measure, because that's exactly what you'll get.
Yeah.
Got it.
Wow, that was beautiful and short and to the point, and I think that's a great way to end it for this episode. So that's a wrap for Pop Goes the Stack. Subscribe now so you don't miss the next innovation that'll break staging before it breaks production.